what is that? Domain and range of a graph in interval notation. So let's look at the domain. Domain is left to right. Domain. Left to right in interval notation. Where does this graph exist in interval notation? So where does it start? Could you tell me? -5. You don't see an arrow like insinuating that it keeps on going, right? -5 domain. -5. So from left to right, reading left to right, we start at -5, we go, 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 go. Is that an empty dot, is it?
Yeah.
So what does that mean to you?
It doesn't include -3.
It excludes, it does not include -3. So what we'll do there is, comma, stop at -3 with a bracket or parentheses. Parentheses means disclude. Or that's not a word, exclude. Exclude is not a word. All right, so the graph does continue. Where does it continue off of? Well, it starts again at -3, and it just keeps on going. So -3 to infinity. That's our domain. Yeah, at 1 we have a solid dot, so that includes that. It's not, yeah, I uploaded to Canvas, guys. Yeah, so let's just hear me, please. Avoid side conversations. So a question was, what's happening at 1? Well, there is a solid dot, but it's not an empty dot. If it was an empty dot, it means that we exclude that 1 here. So that's why we stop it at -3 with the parentheses, and we start at -3 with the parentheses, and just keep on going. Don't stop there, all the way to positive infinity. So our domain in interval notation is right there. -5, comma, -3. So now let's get our range. Range, we're looking bottom to top. How are we moving? Bottom to top, where do we start? -4. -4. So looking from the bottom, -4 we start, we go up, 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 up. And a point is that, like one argument is that, well, don't we exclude 2 here? There is an empty dot at 2, so would we stop at 2?
No.
Well, if you're going up to down, it does cross at another point, so there's no discontinuity. It's from the bottom at -5, it doesn't stop anywhere. Every point is accounted for. So it just keeps on going up to positive. So our range is -4 to positive infinity. All right, moving on. So we'll start with our notes. We're doing section 1.2, part 2, notes. we started a little bit on this. Shh, guys, quiet. We started a little bit on this last class on Friday, finding the y-intercept, x-intercept. So here it is. Find the y-intercept and zeros of the function. The y-intercept is where x equals 0. On the graph, could you say what does it look like? On the graph, where is it crossing?
It goes
Y-axis, thank you. Vertical, the y-axis it crosses. So that's where x equals 0. So that's why we say y-intercept is where x equals 0. The x-intercept, also known as the zeros, are where y equals 0. So graphically, on a graph, I mean, the roots, the zeros, where it crosses the horizontal line. The x-axis, very good. And we just set that equal to y equals 0. So in these examples, and a lot like on the test on Friday, you won't have a graph to just say, oh, there it is, there's our zeros, there's our y-intercept. Just with a function, just given a function, you just have to plug in x equals 0, find the y-intercept. Plug in y equals 0, find the x-intercept. So let's do that right now. The y-intercept's right here. It's just going to be 1 this time. Y-intercept is where x equals 0. So let's plug in 0. F of 0 equals 0 plus 15. And on the bottom, where there's a 0, plug in a 0. So just plug in the 0 for x. The output you get from that is your y-intercept. So what are we getting? Top is 15, bottom is negative 5. 15 divided by 5 is, you get negative 3. So there's our y-intercept. Let's write it as a coordinate point, an xy point. X is 0, y is negative 3. There's our x-intercept. Just like we said, where the y-axis, the vertical line axis, where it crosses that, x equals 0, and it's at negative 3, y equals negative 3. All right, find the x-intercept is a little bit more complicated. X-intercepts, also known as the zeros. The zeros of the function that crosses the x-axis. What do we say? What do we set equal to 0? Y. So the output, f of x, where f of x equals 0. So set this equal to 0. 0 equals x plus 15, x squared minus 2x minus 5. So here we are. What x's get us an output of 0 is the question. What x's plug in here and get us 0? Right now it's very complicated because it's a fraction, it's a rational function right now. So it's hard. But here's what happens. Factor, even before that, I'll tell you, something that happens is the denominator totally disappears. And how is that? How is that all of this?
You multiply that to 0.
Multiply this to both sides. X squared minus 2x minus 5, and multiply to the left side. So what happens? That just totally disappears. Cross out, x plus 15 on the left side. And all of this times 0, what happens to it? It burns to 0. So how about that? So what that meant was none of that denominator mattered to us. None of the bottom mattered. you can just burn it out. When you're trying to find the x-intercept and the left side is 0, the output is 0, you can just remove it. So I heard a negative 15. So what x makes us, what was I trying to say? When y is 0, x is negative 15. All right, so there's our one intercept, or 1, 0. Let's write it as a coordinate point, negative 15, comma 0. There we go. Let me know if I'm going a little too fast, if you need to still copy things down. We'll do 2 or 3 more problems just like this. And it's always the same step. Step 1, set x equal to 0, find our output. Step 2, set y equal to 0, find our input. So once you're done jotting down, we'll move on. I think we're done. Let me know. All right, example 2. Find the y-intercepts and the zeros of the function. So 2 parts. Y-intercept. Y-intercept, set x equals 0. F of 0 equals, well, wherever x is, you put a 0. There you go. Hey, a lot like the last problem. I think it's going to be the same number. Coincidence, just a coincidence. Set x equal to 0, we plug in 0. What do we get? Top is negative 15, bottom is 5. So that's a coincidence. Ended up just like last problem. So what's our y-intercept? As a coordinate point, xy coordinate point? Negative 3, 0. Yeah, no problem. Negative 3, 0 is our coordinate point. Oh, I'm sorry. 0, negative 3. Thank you. That happens sometimes to me. 0 is x, y is negative 3. All right, step 2 are x-intercepts. That is loud. That's okay. Our zeros. What do? We set y equals 0. So our f of x is 0. We leave our x alone. We're trying to find what x's get us a y equals 0. What x's get us a y equals 0? Okay. Well, what do we do in the first problem? What happened to the whole denominator?
You multiplied it and then it went away.
It went away. I like to think of it just burns to 0. We can just burn it to the left side. So 0 equals 2x squared plus x minus 15. All right. So now factor. Yes. Solving is good. Solve for x, but we can't do that without factoring. So y'all take a look at that. See how y'all factored this, like in Algebra 1 and Algebra 2. We did a lot of factoring there. Well, y'all did.
2x minus 5, x plus 3.
What'd you get? I'm not sure. So some of y'all know how to factor. Good job. Some of y'all, I think she had it too. So if y'all know how to do a factor, that's just like plus, minus, multiply, divide. That's so foundational. We have to know that in pre-cal. So in this section, it's going to be one opportunity to really practice your factoring. But that's just a required prerequisite knowledge you have. But I'll go ahead and show you how I factor this. I factor by slide, divide, bottoms up. Did you hear that? You've heard that before?
I didn't, nobody taught it to me here.
Good. But it's like the easiest way. Good. It is like the easiest way. I always did it by grouping, like guessing and checking. But once I learned slide, divide, bottoms up, any quadratic was easy to factor. So here's your chance to learn it. We'll do another one next example. But really put this one in your pocket. Save this tool for yourself. All right, slide. What does that mean? 2 goes to the end. 2 goes to the end. What does that mean? It multiplies to 15. 30. Because factoring is hard when you got a number in front of the x squared. When you have a leading coefficient, it's hard. Now it's gone. Now, factoring principle thing you're trying to find is 2 numbers that multiply to negative 30, but add to what? To 1, the middle number. Multiply to the end number, add to the middle number. 2 numbers. Think about it. 6 and 5. One of them's negative.
Negative 5.
Add to the middle number.
6 and negative 5. 6, negative 5.
There we go. X plus 6, x minus 5. That gets us that quadratic up there, right? You multiply it out, you'll get that.
Yes.
Multiplies to negative 30, adds to plus x. All right, next step is divide. The next step is called divide. We divide by that original leading coefficient. What was that coefficient? 2. So you divide each of those numbers by 2. That's the divide part. Slide, divide, bottoms up. Next, 0 equals, well, let's simplify. X plus 6 over 2, what is that? 3. X plus 5 divided by 2. That doesn't divide into 5, does it? 2 doesn't divide into 5. No. So leave it alone for now. So whenever you get a situation where you can't divide, you do the bottoms up. The bottoms up. And what does bottoms up entail? You take that bottom denominator, pull it to the front of the x. Just as that arrow is implying. So what we got is x plus 3, 2x minus 5. There, that's factor. And that's what Raymond, yeah. That's there. Thank you, Raymond. That's what you got. Good. Yeah, so where we're at right now, like you said, negative 3. 0 equals x plus 3. 0 equals 2x. Shh, guys. 2x minus 5. So we are going to have 2 answers for our x-intercept. Negative 3 equals x. And what happens to that guy? Move the 5, divide the 2.
So what's the point of the bottoms up part? It's just going to go back
that's just what you got to do to get the right factorization in the end. Bottoms up is needed. What's that? You don't have to use it. If you know how to factor them, go ahead. It would be the same thing, but that's not usually how we like to do it. You could leave it that way. So 5 over 2 equals x. Off your phone, please. Put it up. All right, so x is -3, comma 0, and 5 over 2, comma 0. Not in this one, no. Extraneous. Yeah, that's a good point. But if you remove, like in the beginning, we removed all that denominator. If you do that, you won't have extraneous solutions. We're not going to check for extraneous solutions in this section. Yeah, not in this section though, okay? But you can definitely check. You can plug it in and see if it works, but we don't have time for that. We have to keep going. Yeah, let's take it. All right, moving on, guys. All right, find the y-intercepts and x and the zeros of the function. Again, let's do it. Let's speed it up on this one. Y-intercepts on the left side. X-intercepts, also known as the zeros. So y-intercept set x equals 0. F of 0 equals 6. Just plug in the x as 0. -2 divided by -1, yeah, 2. So our y-intercept is 0, comma 2. Got it. What's next? X-intercepts. So set f of x, or y, equal to 0. 0 equals 6x squared plus x minus 2 over x minus 1. Like the last problem, the bottom burns out. 0 equals 6x squared plus x minus 2. We want to factor that. Using slide divide bottoms up, I'm going to do that. What two numbers multiply to -12 add to 1? 4 and 3, yeah. Okay. We did slide. We didn't do divide yet. X minus 3 divided by 6. 4 divided by 6.
Did you do the x2 plus x just to make the factoring easier?
Did I?
Because we changed to 6x2 plus x
Yes, that's part of the slide divide bottoms up method. The main idea is why this is easy is once you slide, you don't have a leading coefficient of, you don't have the leading coefficient. So we got 0 equals x minus 3 over 6. What does that simplify to? 1/2. 4 over 6. That simplifies to 2 over 3. And then you do the bottoms up. But someone made a point of saying that you don't have to. Aren't the answers right there? X equals 1/2 and x equals negative 2/3. Those are the two x's. Yeah. So even if you slide it to the front, it looks nice, and we'll go ahead and do it. But our answers are back up there. X equals 1/2 and x equals negative 2/3.
It's negative 1/2. It's x equals negative 1/2.
No, it's positive 1/2.
Oh, we can do this way.
It's the opposite sign of what's in the factor. So our 2 points are 1/2 comma 0, negative 2/3 comma 0. And yeah, normally you do check for extraneous solutions. Well, Raymond, can you say what's the purpose of checking for extraneous solutions? Yeah, you're the one who said it, right? What's the purpose of checking for extraneous solutions?
To find out if the answer doesn't work in the graph.
Yeah. For the most part, when you plug it back in, you see if you don't get an error, if you don't get divided by 0. We won't be doing in this one, but that is a point. That is something you do. Plug back and see if it works. But here we are. We got our y, x-intercepts are 0s, and we got our y-intercepts. So moving along, I'm going to skip. I am going to skip this one. But y'all could do that on your own. If you're just skipping that one. Yeah, we got to keep going. Like, we have to move on to the next topic.
In Canvas, do you have the finished notes, or is it just?
No, it's just this. But I record this, so the completed notes will be in the video.
No, we can't get on YouTube.
It's called like Mr. Thomas.
We can't get on YouTube anymore.
We can do it at home though.
Not on these.
Yeah, you'll find a way.
Education notes will just be online.
Oh, gotta keep going. All right, guys, gotta keep going. Yeah, this is kind of weird. Us side talking like this. I feel like I'm not in paper class. I'm babysitting or something. Let's be quiet, please. Jeez. Okay. Define an interval notation where the graph is increasing, decreasing, and/or constant. So looking left to right, we're going to define an interval notation where it's decreasing, where it's increasing, where it's constant. So let's start with increase. So looking left to right, reading from left to right, that one looks like it's going down. Stop it. Sorry. Bothering me. I'll go ahead and move you, that's fine. Just not today, because I want to get through this. That one looks like it's decreasing. This one looks like it's increasing, decreasing, or it's staying the same. That one looks like it's, so let's go and write the interval. Or, no, I want to do increasing, right? So there's decreasing.
I'm writing all the points that are increasing.
No, just the interval notation. So from 3 to 5.
And if I had an open circle, would put
I'm sorry, parentheses. I think it passes 4 to 5. Increase from 3 to 5. So now let's do constant. Constant is, like y'all said, where it's flat from -5. But it's an open circle, isn't it?
it's a
Parentheses. And it's flat all the way to 1. And is a bracket or a parentheses at 1? Bracket. Let's see, it's constant here and constant here. So let's put it here. So let's put a bracket 5.
A bracket or whatever.
On 5?
No.
Oh, infinity is always parentheses. Yeah, good thinking. So y'all know open circle means parentheses. Filled in dot means bracket. One more, guys. Decrease.
Wait, so what's the whole thing in the corner?
Which one? That's also decreasing.
But the arrows.
Well, don't read it left to right. Read it. I'm sorry. Don't read it right to left. Read it coming this way.
Okay. Okay.
Question? Yeah, we're decreasing here, union decreasing here. Yeah. Negative infinity, comma, -5, bracket or parentheses? Union, 1, comma, 3, bracket. There we go. So these should be a gimme on to test on Friday. If you have 1 or 2 problems like this, just writing in interval notation, increase, decreasing, where it's constant.
Do you have a review period?
Yeah, on Thursday. Yeah, not posted yet. I'll post it on Thursday. I just said Friday. We have 10 more minutes. We do have a bit of notes today, guys. It's probably until the bell, so let's keep on going. Even versus odd functions. Yeah, it's on Canvas. But not the completed, so you got to complete it in class. But as you see it on here before I write it, that's on Canvas, the ready notes. So a little bit about even functions. Even function is like it looks. It looks even on the left and the right side. There's a symmetry across the y-axis. So if I fold this left to right, it's going to be perfectly symmetrical. And what is that algebraically? That means if I plug in a negative x into the function, I'm going to get the exact same function. So if I plug in a -5, boom, right here, isn't it the same -5 over here? Yes. So algebraically in the function, if I can show, if I plug in a -x, I get the exact same function, f of x, it's even.
So quadratic is even.
Yeah, quadratics are often always even, if it's symmetrical around the y-axis. If it's shifted to the right side, it's not. It's got to be symmetrical across the y-axis.
Okay.
Then odd. Odd function is a kind of symmetry that's rotation. If you rotate this 180 degrees, you get the same function. So symmetry across the origin, it's called origin symmetry. That's called an odd function, even odd. And what's special about odd? If you plug in a -x, you get the exact same function, but totally opposite signs. So I'll show you 2 examples and then you get the idea. For sure. So if you didn't get that, we got to keep going. Well, it's on the canvas. Example, even, odd, or neither. If it's even, it's even. It's odd, it's odd. Neither of those, it's neither. Of course. All right. Is f of x equal to f negative x? In other words, is it even? Well, let's try. F of negative x equals negative x cubed minus 2 negative x. Try it out. See if you simplify all that and you get the exact same function back. You plug in the negative x, you simplify it, see if you get that starting function again. No, you simplify. So what's negative x cubed? Negative x cubed. What's negative 2 times negative 1? I'm sorry, negative x. Positive 2x.
So you don't get the same thing?
No, not the same. So it's not even. So it could be odd or neither. We'll have to try the odd one. So we plug in a negative x, simplify it, and see if we get the opposite signs everywhere. Oh, what did I do?
Wait, so
1 second there.
we already plugged in a negative.
Yeah, we already did this, right? So in the end, we got negative x cubed plus 2x. So the question is f of negative x equal to negative f of x? Is it the same function, but all the signs opposite? Is it the exact same function as the top, but the positive's negative, the negative's positive? It looks like. Positive x cubed became negative x cubed, negative 2x became plus 2x. So yes, it's odd. You get the exact same function. You get positive x cubed and negative 2x.
And then if it was neither?
If you didn't get any kind of pattern like those two, it's neither. If you get, you'll see what happens after one more. Let's do it real quick. So odd means all the signs become opposite. Even means you get the same function again. All right, example 2. F of x equals 4x4 minus 2x squared plus 3. So looking at the exponents, they're all even, aren't they? So this could be an even function, because if I put a negative 1 raised to 4 is positive, right? If it's an even exponent, you'll get the same thing. So let's see what happens. F of negative x So what's negative x raised to 4? Negative 1 times negative 1. 4x to the 4, guys. Negative times a negative times a negative times a negative is a positive. How about the second part?
2x squared. I don't know.
That negative x squared is a positive x. Negative 2 times positive x squared. All right, next up is the plus 3. So is it even? Is it the same function? Same function. So if I put a negative,
Wait,
yeah, what's wrong?
when you multiply 4 times negative 1, it's a negative 4.
4 times,
You have to
Rid of 4 exponent.
you have to raise it to 4 first. When you raise it to 4, it becomes positive. Positive x4.
It starts negative.
All right, we'll do one.